In section 9.3, we're going to learn how to construct a confidence interval for means. In the last section, we looked at constructing confidence intervals for proportions, and we did this in situations where we were keeping track of categorical variables, such as batting average or free throw percentage. But in other situations, we measure an athlete's ability by giving the mean or the average based on numerical variables. For example, in baseball, hitters can keep track of the average number of home runs they hit per season. For example, if they play in 5 seasons, maybe one year they hit 22 home runs, and then the next year they hit 27 home runs, and then 19, 23, and 26. And then they can average those together to get an average number of home runs per season. In basketball, players might keep track of the average number of points they score per game. Now, just like before, we can never know an athlete's true ability and we can't measure it. So, what we're going to do then is we're going to calculate a confidence interval to find a plausible range for their true ability. Now, we're going to start off again with a formula, and this is for a 95% confidence interval for one mean. Now, when we're talking about an unknown ability that we're trying to estimate, the symbol that we use for the mean is lowercase Greek letter mu. And here is the formula that we're going to use. So we have x bar, which you recognize as the symbol for a sample mean, plus or minus 2, and then we're going to multiply that by s over the square root of n. Notice that this confidence interval has the same general format as the formula we used in the last section. So let's define the variables that we're using. Again, mu represents the true ability of the athlete that we're trying to estimate. X bar is the observed mean based on a performance that we actually have data about. S is the observed standard deviation of the performances. And then N, just like in the last formula, is the number of attempts or the sample size. And you'll notice that there's a 2 in that formula, again, because in order to capture 95% of the data, if the data is normally distributed, we need to go out 2 standard deviations. In example number 1, it says that in the 2017 season, at the age of 40, Tom Brady led the NFL in passing yards playing for the New England Patriots. In the 16 games in that regular season, he averaged 286.1 yards per game, with a standard deviation of 65.1 yards per game. This is our single value estimate because it's based on one season. And we're going to use that to calculate a 95% confidence interval for Brady's true passing ability. So let's get all the numbers substituted into the formula. Notice I put parentheses around the fraction part, but it's not necessary to do that. So the 286.1 is the X bar in the formula. We do plus or minus 2. The 65.1 is S, the standard deviation, which is provided in the formula, or in the problem rather. And then the 16 in the denominator is our sample size because we're getting data from 16 games. Now, like we did in the last section, I would recommend that you calculate this part first, which will give you your margin of error. And you can simply type in 2 times 65.1 divided by the square root of 16, and that will give you a margin of error of 32.6. And typically with means, we'll go to one or two places. Since the numbers given in the problem are going to one place, we'll also round to one place and save all your rounding for the end. So we have 286.1 plus or minus a margin of error of 32.6. Another way that we can write that interval is to say we're going from 253.5 to 318.7. Now, if we interpret this confidence interval in context, we would say we are 95% confident that Tom Brady's true passing ability is between 253.5 and 318.7. And when you're working with means, it's really important to put in their units. And so what we're calculating here is yards per game. So don't forget to include that. Now we're going to look at 2 seasons where Brady played for Tampa Bay, and we're going to look at 2020 and the 2021 season. And during these 2 seasons, he had 33 games, so we have more data to work with. During that time, he averaged 301.5 passing yards per game with a standard deviation of 76.5 yards per game. So we're going to calculate the confidence interval based on these games when he played for Tampa Bay. I would recommend that you pause the video and try the calculation and then restart it and see how you did. Okay, here's the formula with all the numbers substituted in. When we calculate the margin of error, we get 301.5. That's our single value performance that we're calculating our interval based on. And our margin of error this time is 26.6. Now notice in this one compared to part A, we ended up with a smaller margin of error. Even though the standard deviation was a little bit bigger, we still got a smaller margin of error. And the reason for that is because we have more data, right? When we put a bigger number in the denominator, we end up with a smaller number overall. So more data gives us a smaller margin of error, which means that our interval can be a little bit more precise. So this time the interval for his ability is 274.9 yards up to 328.1 yards. Now, his career average as of August 1st, 2022 is 264.1 yards per game. And we want to know, like, if we think of this sort of maybe as an estimate of his true ability, since it's based on his entire career, we want to know if either of our intervals from either part A or part C capture this value. And as it turns out, the first one that we calculated in part A does. The one that we calculated in part C does not. But we know that with 95% confidence intervals, we're going to miss the value that we're trying to estimate about 5% of the time. So that's okay. Let's look at another example. And this one is similar in terms of the type of problem it is, but the way that you're presented with the data is a little bit different. So now we're looking at Walter Payton, who played in the NFL back in 1985 and 86, actually throughout the 80s, but we're just going to look at this one season. And in that year, when he played for the Chicago Bears, they had a really, really good season. And instead of having the average number of rushing yards for the season, we're actually given the number of rushing yards that he got in all of the games during that season. So here you're given a list of raw data instead of the summary statistics. What I would do is I would start by putting this data into list one in your calculator. And you can just type them in the order that they're given in your notes. It doesn't have to be in order smallest to biggest or anything like that. Because, excuse me, from that data, we need the mean and we need the standard deviation. So if you put that into your list and then do the one variable stats, you'll get those numbers. So our best guess of Walter Payton's rushing ability during the 85-86 season would be 96.9 yards per game, because that would be the mean of that list of data. And notice I'm using the symbol there, X bar, because that is our sample mean. It's the mean of those 16 games. Now the standard deviation for this data is 44.6, and I'm going to round both of those to one decimal place. Now, part B is asking us to calculate a 95% confidence interval for Peyton's rushing ability during that season. And we're going to use the same formula that we did in the last example with Tom Brady. So we'll substitute the numbers in. Now here I did not put parentheses around the fraction part of that formula, and it's okay either way. It doesn't really matter, just whatever is easier for you. When we calculate the margin of error, we get a margin of error of 22.3 yards per game. And so our interval then is from 74.6 up to 119.2 yards per game. Now, if we interpret that interval in context, we would say we are 95% confident that Peyton's true rushing ability is between 74.6 and 119.2 yards per game. Again, remember to include your confidence level. You're going to indicate the ability that you're trying to estimate, which in this case is his rushing ability. And then we stated the interval, including units. Now, rushing for at least 100 yards in a game is an accomplishment for running backs in the NFL. Is it possible that Walter Payton's ability was at least 100 yards? Well, if we look at the interval, you'll notice that 100 is definitely in that interval. It's between 74.6 and 119.2. So we can say that yes, because 100 yards is in the interval of plausible values, it is possible that his ability is at least 100 yards. Please do homework 9.3 in your assignment packet.